just like a little tutorial thingy for this jump, which I think is really a cool jump to try out with the angle solver. So first of all, what do we have here? We have one full jump, run tick, jump, run tick, jump. And the angle solver does all the rest essentially. So first of all, every tick that is spent on the ground must have a slippery value of default, which in this case is 0.6. You need to expand this tick and set this to 0.6. You can, to copy it, hold the Alt key and drag the constraint, or in this case the state, around. If you want to delete it, you click on it and click on the little X here. So this jump essentially is done. You do one jump backwards, one jump forward, and then do the jump itself. And this is the one jump backwards, run tick, jump, forward, run tick, jump, the jump itself. And now we need to add constraints, and these constraints are quite trivial. I have for now disabled them. Let me actually enable them again. So this is how the constraints look like. They might feel first a little unintuitive, but essentially what we do is we jump from the start position. You can drag around wherever you want, but let's put it here as a start position. And the first thing is the tick where it lands, or no, the tick where it jumps from, sorry, must be on this pane essentially. And this is what we tell it here. So the pane on the Z direction goes from this edge right to the block's edge. And this is exactly 0.2 to 1.7. And then we also have the X constraint, which is the pane's width. And that goes from these two values. And you can see that highlighted in the constraint visualization here. So you jump and you must be somewhere on this pane when spending your last tick running. This is essentially what this first constraint does. We again have the slipperiness default value here. Okay, then we jump again, and again, we need to land somewhere on this pane on the second jump. This is what these constraints do. I just copy pasted them down here on the second jump. Then the jump tick itself, and this is the constraint highlighted now here, the jump tick itself must still be in front of this block. If we would not set this, it would collide into this block because the jump tick itself can't be beside this block already. We don't have enough momentum for this. So it must be in front of this. But the next tick, X, or the tick after jumping, can be in front of this block or this edge. And this is what we say here. So first of all, stay in front here on the tick where space is pressed and be next to this block on the tick after that. This is what these constraints say. And then there's still one more constraint, and those are these two. They are a bit misaligned, and they essentially just say, okay, we need to pass this edge right here. And this edge is X facing. What this means is we need to pass the edge to the right side of me before we can enter the neo. And this is what is expressed here. So first of all, we need to be in front of this side, which is X minus 9.3. X must be smaller, equal minus 9.3. So we must be behind this edge, but we also want to pass the Z side of it. So we can pass the edge on the next tick. And the Z side is exactly where this constraint is pointing at the point or 3.3. And this is what is essentially set here. And then there's just a final tick, which is the land tick. And this just defines the pane here. And all of this can be set up really, really quickly. Like, for example, let me select tick 34 in this case. I can press X. Now I have removed all the constraints. Now I can face this block side, press B, have added this side as a constraint, face on this side, B, have added this side as a constraint. And now the only thing you need to do is click on solve. Everything else here is not necessary. I mean, yes, you want to start tick 1 and at tick 38 with the optimization. We do not really care for solving for a axis. In this case, you would want to maximize Z because, no, you want to maximize X, sorry, because you want to get as far as possible onto this pane. And we're here on the X-axis. But this is really not necessary. This is really not necessary. And now we can just click on solve and it runs for a bit and it has found a solution already. Now let's look at the solution. And as we see, we landed. And the cool thing is it figured out all the inputs. Well, in this case, it's just W and A spam and all the angles for you. Like, let's load this in again. let's maybe try a different starting position. Let's place it here and see if it can find still a solve. And it did find a solve. And this is how easy you can not necessarily strat find, but validate if a jump is possible. Because of course, these angles are not hittable in a real scenario. But this is a very, not thought out tutorial, but I thought I might share this with you on my second channel.